All right, so this is section 9.3 in your book. It might be 9.1 through 9.3, I'm not sure, but it's chapter 9 nonetheless, and it talks about absolute value. Okay, and this goes along with, so we've done linear equations and we've done linear inequalities. Now we're going to do the absolute value of linear equations and the absolute value of linear equalities. Okay, so absolute value, what does that even mean? Okay, absolute value is distance. Okay, it's distance on a number line from 0 and is denoted by these two bars, right? You probably know what that looks like. Okay, so if I'm on a number line, let's see what I'm talking about. Distance, right? So if I'm right here and I'm gonna draw a little stick guy. Don't make fun of my drawing here. If I'm at 0, right, on, let's say I'm on a sidewalk, I can walk 4 paces this way, right? Or I could walk 4 paces this way. Okay. And would you agree that either way, whether I went to the left or to the right, I went a distance of 4 paces, right? That's why the absolute value of numbers is always positive. Okay. The absolute value of a positive or a negative number is positive because we're talking about distance. Okay. And the absolute value of 0 is 0. Okay. So whether I go 4 paces to the left or 4 paces to the right, that's still 4. Okay. So that's what we're talking about when we talk about absolute value. Okay. So here's how to solve absolute value equations. Okay. So we're talking equal sign, right? So if necessary, we're going to get the absolute value expression by itself. So you should have a set of bars and then equal sign and then everything else. Okay. So we're going to drop the absolute value bars and make 2 equations. Okay. So we're going to want our, whatever is inside those bars, we're going to want that equal to the positive and the negative because we're talking about distance, right? So we're doing the absolute value, so we have to account for the positive and the negative because it's distance. So we can go either way, right? We can either go this way on the number line or this way on the number line when we're talking about distance, and that's equals the same thing, right? If this is -4 and this is 4, when it comes to distance, it's just 4, right? So that's how we're going to do that. And then this says make sure you get the absolute value bars on the left side by themselves before you set up the problem. Okay. So look, we have the absolute value of 4x plus 2 equals 5. Okay. So our absolute value is by itself on one side, and then it equals everything else. Okay. So we're going to make 2 equations. We're going to have 4x plus 2 equal to 5. And we'll have 4x plus 2 equal to -5. Then you just solve each of them separately, right? -2 is 3, divide by 4. Okay, same thing over here, subtract 2. But this time we're subtracting 2 from -5, so we get -7, divide by 4. So we have 2 answers. X equals 3/4, and it equals -7/4, okay? So drop the absolute value bars, positive and negative, okay? On this one, before we do our equation, we have to make sure that it's by itself, right? We need this part by itself, okay? So if we add 6 to both sides, okay, then we can divide by 4, creating 1, right? we get 3x, sorry, the absolute value of 3x minus 2 equal to 7. Okay, now we can split it up. 3x minus 2 equals 7. 3x minus 2 equals negative 7. Then we solve. Okay. Again, we get 2 answers, okay? So you may have to do a little bit of manipulation here of just getting the absolute value alone, but once you get the absolute value alone, you set it equal to the positive and the negative, okay? Notice that your absolute value doesn't change. This stays the same. The only thing that changes is what's on the other side of the equal sign, okay? So that is how to solve equations, okay? Equal to. Here's how to solve absolute value less than inequality. Okay, so now we're switching gears to inequalities, not equations. Okay, so this will look like the absolute value of some expression is less than some number. Okay, so if necessary, we're going to get the absolute value expression on the side by itself, right? That's what we did in the previous problem. You just have to add or subtract, divide, just get the absolute value by itself. With the less than problems, okay, I treat them as and or. Okay, we have 2 problems, and problems and or problems. Less than are and problems, okay? And this is the way I think about it. If I have less than, okay, put a D on the end of that, right? Less than. Less than means squeeze, okay? Less than means squeeze, okay? Or some people say make a sandwich, okay? You are going to squeeze the inside between negative C and positive C, okay? So this was the absolute value. You drop the bars and you put positive and negative and have the same looking signs, right? Between. And then you'll graph the solution and you'll put it on as interval notation, okay? The and problems are easier than the or problems because basically you're just making a compound inequality like we just worked, right? That was in the previous video, okay? So let's look. Both of these are and problems, less than, right? So you need to be able to recognize that. That's the hardest part, okay? The absolute value of 3x plus 1 is less than 11. So you need to recognize that this is an and, okay? And means squeeze. Okay, squeeze, make a sandwich, whatever, okay? Identifying those 2 things is probably 60% of the problem, okay? So that means that you're going to drop your absolute value markers. And you need to squeeze it. So we have less than or equal to 11. That's this piece. Okay, we're going to put the same looking sign on the other side. See how they look the same, pointed in the same direction. But you'll do the negative of the number. Okay. Then all you do, and I put 11 and I meant to put 1. Hopefully you caught that. 3x plus 1, not 11. Okay. After that, all you're going to do is keep x in the middle, right? This is a compound inequality. And on compound inequalities, we keep x in the middle, okay? So let's manipulate the middle. That means we're going to create 0 and get negative 12 is less than or equal to 3x less than or equal to 10. divide by 3. That creates 1, right? -4 is less than or equal to x is less than or equal to 10/3. Okay, let's put it on a number line. -4, 10/3 is 3 and some change, right? So let's just put it there. And remember, x is in the middle. This is the same rules as your compound inequality. Okay, x is in the middle, so we color in the middle. Okay, now both of our inequality symbols have equal to signs, so they're both going to have brackets. So if I wanted to take that and write in an interval notation, I start at -4 and I go to 10/3. And both have a bracket. And I'm done. Okay. So less than, squeeze it. Less than means squeeze it and then keep x in the middle. Okay. So look at this one. 2 times the absolute value of x plus 4 minus 6 is less than -2. Okay. Obviously, our absolute value is not by itself, is it? So we need to manipulate first. So we need to say, okay, let's add 6. That gets rid of that. Okay, divide by 2. We created 1 right there. So we get the absolute value of x plus 4 is less than 2, right? Now, we can recognize this is an and statement. Less than, that means squeeze. And statement means squeeze, so we have x plus 4. We drop the bars, is less than 2. And we need to squeeze it. Same sign, negative of the number. Now, keep x in the middle. -6 is less than x is less than -2. Okay, so x is in between -6 and -2. Both of them have parentheses because neither one of them are equal to. So from left to right, -6, -2. Okay, they will always look like this. Okay, they will never have an infinity sign. Okay, they'll never have an infinity sign in them. They'll always be in between two numbers. Okay, and that is how you do less than, right? Less than an and statement. You squeeze it. Okay, let's do greater than. Okay, I told you these are a little more complicated. Okay, these look like this, the greater than symbol. Okay, I call these or statements. Okay, or statements. You have and you have or. Or statements mean we're going to have two different pieces. Okay, two different pieces. So again, if necessary, we're going to get the absolute value expression by itself. That's what we've been doing this whole time, no matter what. Then you're going to drop the absolute value bars and make two problems. Okay, that's what I mean by two pieces. We're going to have two problems. You're going to have x greater than c or x less than -c. So here, you're going to have x is greater than c. Then you're going to have x less than, so you're going to flip the sign, take the negative of the number. Okay, flip the sign, negative of the number. All right. And then this little box over here is just reminding you how we write interval notation, right, from left to right. All right, so let's look at this guy. We need to, all right, identify and or. Like, these are these are all or statements, but we read this as the absolute value of 3x minus 8 is greater than 7. And I can write that up here. That's how I remember it. Greater than. Okay, less than, greater than. Or statement. 2 pieces. Okay, I need 2 pieces. So I have 3x minus 8 is greater than 7. Notice all I did was drop the bars. This piece is the same as this piece. Or I have 3x minus 8. 3x minus 8 does not change, remember? Only your number on the outside, on the other side. So I have greater than, so I need to do less than -7. The only thing that changed was less than and negative. Okay, now I'm going to solve each one separately. So I'll add 8. Divide by 3. Add 8. Okay, so I have these 2 things going on. X is greater than 5, or it's less than 1/3. Okay, so let's look at what that looks like on a number line. 1/3. I'm gonna do it in a different color. Let's do it right here. All right, 1/3. And then 5's right here. Okay. Look at each of these. Put these on the number line separately, okay? X is greater than 5. 5's right here, and I'm greater than 5. So I'm all these numbers, right? Then X is less than 1/3. So I'm all these numbers. Notice how on or statements, I do everything this way. In and statements, I did everything in between. Okay. And or statements are exactly the opposite of one another. Okay. Or statements have nothing in common. And statements have everything in common. Okay. So if I were to write this in interval notation from left to right, okay, here's my left. Something's going on right here. Okay, so I'm treating them as 2 separate things. So from left to right, I'm starting at -infinity and I'm going to 1/3. Then I jump over to 5 and go to infinity, right? And I have parentheses on all of these, right? And then, if you may remember this, the union symbol, union in math means or, right? And these are or statements, right? It all kind of makes sense like that, okay? You put your union symbol in between it. Okay? So or statements, nothing in common. And statements, everything in common. Okay? These always look like this. They always have negative infinity all the way on the left, and they always have positive infinity all on the right. Okay? So let's do another one of those. Okay, we need to create our 2 equations, not equations, inequalities, sorry. Or 3x minus 3 over 9. less than or equal to -1. Okay, flip the sign, change to negative. Now we need to solve for x. So this has a fraction in it. We need to get rid of it. Okay, this is just basic solving inequalities. Hopefully by now you're more comfortable with this. That's why I'm kind of going faster. Okay, same thing over here. We'll multiply by 9. Okay, so we got x is greater than 4, or it's less than or equal to -2. So here's -2, here's 4. Okay, we know that they should have nothing in common. Okay, they should look like this. They should not look like this. If they do, you're wrong. Okay, so x is less than -2 means we're all these, and I'm going to have brackets. Greater than 4, greater than or equal to 4. Looks like that. Left to right, remember? Left, right, left, right. So we should have negative infinity to -2, union 4, infinity. Okay, this is your answer. All right, so these problems always look like this. Or statements, greater than, 2 pieces. They have nothing in common, okay? And statements have everything in common. Oh, let me go back. There we go. And statements have everything in common, right? You're shading in the middle. So you make a sandwich, you squeeze them together. Less than, squeeze them together. Make a compound inequality, okay?